is relevant even to myself as kind of a synthetic chemist. This stuff does come up. And again, gases and liquids. I'm going to put this in context of the bends, which is what divers get. As I mentioned, free diving, you can only go so far because nitrogen gets in your blood, and if you rise too fast, bubbles of nitrogen appear in your bloodstream. And for weird reasons, I never understood if a cavity via a bubble or a particle is in your bloodstream, and if it gets to a certain critical size, your heart will stop. I have no idea why. I never got that. It doesn't have to be too very big, like a small bubble, but your heart freaks out and will just stop. One of my former undergrads who worked in my research room, her aunt died that way. She was at a hospital and the nurses were not looking after her. They had her connected to an IV to hydrate her, right? They seem to always do that. That's to hydrate you. And the liquid ran out and air got in and she died, heart attack. So that's why this is relevant. Now, what I like about Henry's Law questions is that it comes in a very bare bones form. It comes in the form of a coefficient. In the case of N2, in, what am I doing, H2O, it comes in this form. This is all I'm going to give you. 1.56 times 10 CV5 kilopascal kilogram per mole. Okay. So again, this is the test. I'm going to ask a Henry's Law question, and here's the Henry's Law constant. Now notice that there's a mess of units, and I'm not telling you what to do with it. So this is what I like about this. And remember, early on I said, you don't know units as well as you think, right? And maybe it was true, maybe it wasn't, whatever. You've got a mess of unit questions. Hopefully you got over it. And this is valuable right here. So I'm going to give you this, but I'm not going to tell you how to use it. So I'm giving you this. Now you have a question. What's the question? Let's see. So the question is moles. Sorry, I'm not going to write this out nicely. Moles of N2 in 1 kilogram H2O at 1 bar. Okay, so that's the question. How many moles of N2, sorry, I'm not writing it out nicely. How many moles of N2 are in 1 kilogram of water at 1 bar? And here's the Henry's Law coefficient. Give me an answer, right? So again, this is the test. You've got to figure this out. Again, what I like about this is that you've got to work the units.
Does this supposed to be bars?
What's that?
Kilopascals to bars?
Well, hold on. Let's just, hold on one second. Let's take it easy. Let's go step by step. Now, noticing that that I'm going to give you a question. I'm going to actually give you a much harder question, but I'll give you an example in a minute. Let's just do baby steps. Let's figure out how to use this thing. All right. Now, I think the smartest thing to do is look at the question. And I noticed, right, I do have a conversion issue. So what I want to do is just write down. So here's the answer. Okay, that's the question. Here's the answer. Not looking at the board too well today. What I want to do is write down the pressure of kPa N2. Right, that would be the pressure of N2 at 1 bar pressure, right? Really? Sure? What did I just say a little while ago? How much nitrogen is in the atmosphere?
A lot.
Is it 100%?
75.
75. Okay, it's 75. I will give you that information, by the way. It's just a little bit of that. The air is actually 75% nitrogen, so I will include that in the question. If you use it or not, 1 point, won't be a big deal. Okay, so 1 bar, roughly 75 kilopascals nitrogen. You know that you have to get to this number of moles of N2 if you have this, and I'm not giving you anything else. Now, hopefully you would realize that you're going to take this thing, and you've got 2 options. So let's, by the way, let's call this K. Right, because that's what I called it in the last lecture. Okay, now you've got 2 options. We're going to do that option, and then hopefully we're going to be at the answer, maybe not. I can either take K on top or K on bottom. In other words, either I'm going to divide K by this number, or I'm going to take this number and divide it by K, with the end goal of getting moles of N2. Which is it? There's 1 vote for bottom. What do you think's top? So do I take this and divide by 75? Or do I take 75 and divide it by that?
Divide by that.
Okay, yeah, you all got it right. Divide by this. And the reason is because I'll get moles on top. Right, so that makes sense. So 1.56 times 110 to the 5. Okay, so notice that my pressures have canceled. And now I've got the answer. Is that right? Is that right? Now remember, I'm supposed to end up with moles of N2. Have I? Know what I need to do. Multiply by, multiply by 1 kilogram H2O. And this is, by the way, a very small number, so use your calculators. I don't like a bunch of zeros, so this is 0.048 millimoles of N2. Sorry, right now. Okay, so again, the point of this is I'm going to give you a question. I'm not going to give you much information. I'm not going to baby you to how to work this. You're just going to figure it out. And you can figure it out based on units, and that's why I kind of like this question. If you convert this to volume, I think I did. Did I do that? No, I don't think I did that. I don't quite remember what the volume is, but it's definitely appreciable. Okay. Now that was the baby question. I'm not going to have that simple a question. You had that kind of question in freshman chem, but I'm going to ask you something a little bit more complicated, and as usual, I try to make it relevant. Okay, so let's take so here's the question. 90 kilograms of H2O at 20 meters depth. Let's see. And goes to the top of the water. Okay, again, sorry that I'm not writing this very nicely. I just don't have room. I keep writing a bunch of stuff. Okay, so let me say in words what I didn't write. This 90 kilogram sack of water is at 20 meters depth. I'll tell you what the pressure is. It's 3 atmospheres. This 90 kilogram sack of water is at 3 atmospheres. And it's going to go to the top. And I want to know how much nitrogen is released from the sack of water. What is the sack of water? What does it sound like? What's 90 kilograms? It's a person. It's a person. Right. Okay, now here's other information I will give you. Here's the top of the water. Here's a little ship. This looks like a good one. And they're smoking something. Why? Anyway, okay, so that's at 0 meters, then at 10 meters and 20 meters, you've got yourself 2 atmospheres, you got yourself 3 atmospheres. This is where people miss this question a lot, is that you forget that at 0 meters you're at 1 atmosphere. That's what you tend to forget. All right, so, and I'll explain that in a minute. So again, what I'm doing here is obviously I'm doing a case of the bend. So a diver has gone 20 meters, about as far as a person. 3 divers can go, I think, 100 meters. That's just, I don't know. It's actually illegal to do things that are extremely dangerous because it's basically an act of suicide. Like if you're Eva Knievel and you want to jump over the Grand Canyon, they actually won't let you do it if they really think there's a high probability of death. And if you do it like base jumpers, you will get arrested because just some things are just utterly stupid. And if you do something really stupid and splat, someone's got to come clean it up, right? So anyway, I just find that free divers, I think it's just like, I just wonder how close to death I can go, and that's like the competition, which isn't really a competition. So anyway, so what happened was people were building, when this was discovered, people were building the Brooklyn Bridge, and I don't know, 18-something, 1880, 1860, and what they had were diving bells. You probably know what that is. I actually envisioned one of these when I was a little kid. I wanted to build one of these, which is, of course, just this platform that you invert so it makes an air bubble, and then people are inside of it, and here's the water. Here's the person along deck smoking up. Anyway, And so what they can do is dive underneath. And what they did was they went to the bottom of, let me remind myself, that's the East River, not the Hudson River, the East River. They went to the bottom of the East River and they started digging out the foundation for the Brooklyn Bridge. Now, the East River is not that deep, but they were down there a long time, and when they were coming up, they were either getting just messed up. I mean, they call them sick, but that really what doesn't describe it. They were messed up or they died. It was a physical chemist who figured out that it was Henry's Law, it was the bends. It wasn't Henry, but anyway, that's what they figured out. And so that's why I like to bring this up, because physical chemists actually, maybe save one of your great-great-grandfathers or something like that. And of course, the solution, by the way, was to use helium. And that's why whenever you look at the Nature Channel and you see these deep sea divers, that's why they have high squeaky voices, because they're breathing in helium. That prevents this from happening. Okay, now here's the handy-dandy way of doing this. Okay, let's do the percent nitrogen, 0.75. Sorry, that looks awful. Now, of course, I will tell you that in the problem because I don't want you to do that. Times the pressure, 3 atmospheres would be, now remember I use atmospheres, so that's 303 kilopascals. Because this is a units question, I'm going to I'm going to monitor whether you pay attention to this. Okay, I've got 90 kilograms. Okay, and the reason I know this, to do this, as I'm looking at the number up there, these tend to be very big numbers. And remember, it's a big number because it's 1 over how much dissolves, which isn't much. Kilogram per mole. Remember, I always hate it when I have 1 over x. I hate that. It's x, right? And I have to sometimes use my calculator to remember 1 over x is actually x. So that's how I know I've got moles. Okay, now, here's where this gets kind of funky. You got to do the same thing. So this is what most people miss in doing these questions. I won't write the whole thing out. Well, I will because I'm OCD. I think I'm getting worse too. Okay, so you set this up, and then you forget this. You get most credit. You put that, you get full credit, and just work with me. The answer is 0.087 moles of N2, which as an extra bonus, because I think this is a giveaway, I would have you figure out what the volume is via P equals nRT, 2.1 liters. Now folks, can you imagine what it'd be like to have 2.1 liters of air suddenly appear inside of your body? And not in your stomach, which would probably still kill you, in your blood. What a way to go, right? And it's both, God, I hate to bring this up to you, especially if your family ever had this happen to you. This really hurts. Of all the ways you could go, this is one of the most painful ways to die, and it's not even that quick. So, just thought I'd throw some horror at you. Another thing you can do here, notice that there's actually a shortcut. You could actually just take 303 and minus 101. In this, you could just take 303 minus 101 and put it right here, and that'll get you the answer quicker. Other factoids to note. See, I got some other bits of information. So this is the answer. So this is an aside. The reason that we like to use helium, K is a bigger number. So remember a bigger number. So maybe I could ask a question on this. Maybe this would be a true or false question. Kilogram per mole. Now I've always kind of been fascinated by this. Okay, so you give divers helium. You give divers helium because the Henry's Law coefficient is bigger, and that's going to make less volume. But it's not that much bigger. Now, I know that that's what they do because I see it on the Discovery Channel, but it's not even a factor of 2. Let's call it a factor of 2. If you have 2 liters appearing in your blood, you're going to die. If you have 1 liter of gas appearing in your blood, you're still going to die. So I never really quite got that. I mean, it just doesn't seem like it's a solution, but what do I know? I mean, apparently not that much. Okay, here's CO2. The K is very small. And again, that's kilopascals. Kilopascals per kilogram per mole. Okay, so I guess what you can take away from this is that the smaller the number, the better. So I remember when I was your age, there was this, before, internet actually was invented when I was a junior. When I was a junior in college, the internet was invented. I saw the first web browser, and it was actually saved at my university for the guy my brother worked for. He was in the newspaper. They just found the first web page, find it like, oh, here it is. They had a digital copy. It was at the University of North Carolina because it was first previewed there with the guy who my brother used to work for. So I invented the internet. That's my point. What the hell am I talking about? I totally forgot what I'm talking about. What the hell is going on with me today? Okay, why am I talking about that? I utterly don't remember. I'm kind of freaking out now. It was like senior moment. I'm not that old. Yeah. I was in college, right? I was in college. We didn't have the internet at the time, and I'm just kidding. We didn't have the internet at the time, so we always had this urban legend, which the internet's been actually kind of good about getting rid of, a little bit, right? That Guinness used to carbonate their beer with nitrogen, and that's why that's why there was that rattle. That when you opened up the can, that rattle suddenly created a burst of nitrogen. Which they had to do because they had to engineer it, and that's the fizzies with nitrogen and not CO2. Totally a lie. So I do have the stock question. Maybe I'll ask that, where you prove that on the in your next test, or I might do a diving question. I'll do one or the other, so that that this is worth your time. Anyway, the reason that you can tell that Guinness, again, a very old urban legend, Guinness does not carbonate with nitrogen is that the Henry's Law coefficient are roughly 100 times different. So you cannot carbonate something with nitrogen unless you have 100 times the pressure, which means that those little canisters of beer are grenades. They would be about as powerful as a grenade, or it's just not true. So you pick which one it is, right? Little urban legend. Okay, anyway, so that's an example problem. Now let me go ahead and do 2 partial volume questions because there's one on your homework. Again, I feel obliged to put it on your test. These are tricky. Now I don't like these because they're kind of freshman chemistry questions. They're freshman chemistry questions on steroids. They are, again, potentially on your MCAT, so I do feel the need to cover them, even if I don't like them. All right, let's remind ourselves what this looks like. So this is why I'm thinking that you don't quite recognize the question, because this is what we started out with. So remember, this was on Monday, and it really looks nothing like the question that you're being asked on the homework. And I'll have one other test. What? Yeah. Anyway, all right. Okay, so this is what we covered in class. Remember, I said that this is how you calculate the volume of a solution from the different components. And remember, I drew a graph of ethanol water, and I talked about how you could pour the 2 liquids all at once. I just uploaded the video. I actually forgot to do that when I did that before class. Okay, and then the question I asked is very different. So it looks nothing like this, but it is the same. Before I do that, I just want to point out that the partial volumes, and I'll do A, I formally defined it this way. And so this would have units. I just want to remind you that this is what it looked like. Remember, this part was just to remind you that I'm talking about a liquid mixture. Now, this would obviously have units of, I guess, meters cubed per mole to be a purist, be an SI purist. But you're not going to see that. You're never going to see it. I don't like messing with you on units too much. I do it mostly because it is on your standardized tests. And these questions, they really do it on steroids. So what you'll see, you will actually never see meters cubed per mole. Let's see, what have you got? You've got generally milliliters per mole, or you've got milliliters per gram. So you're not SI. Okay, mole, that's what you're supposed to do. Gram. The point is that it doesn't have to be meters cubed per mole times moles. It could be milliliters per mole times mole, or milliliters per gram times gram, right? Really just anything works as long as the units pan out. So again, traditional questions, which I'm going to make sure you know how to do, we'll present these in either case. This is the formula. Let me give you 2 example questions so that you can hack it relatively easy. They are freshman chemistry questions, but they are like the hardest freshman chemistry questions you could have been asked. Okay, so the question is, so I have a 50-50, 50% by 50% by mass, mix of A and B. I rarely identify, I actually use real numbers, but I rarely identify them just because I don't want it to get confusing. The density is 1.5 grams per milliliter. That's kind of high, I just kind of picked that one out of the thin air. And the partial volume of A is 0.7 mils per gram. Okay, then the question is, what is the partial volume of B? Now again, traditional question, it's just a manipulation of units. Here, I'll toss this in here. Now, by the way, this one's easy. The next one is more likely going to be on the test and will be significantly harder, but it's ultimately a units and a calculator question. I feel like it's a giveaway. So I do encourage you to do it, but you will need to stare at it for a little bit of time, but that's why I'm doing this now. So, give you an idea of how to operate. Actually, in business school, this is how I would do this. It's just, look at that mess of information, right? And that equation on top, that doesn't really even seem to help. The trick is start writing down what you know and just make the units work. So in this case, okay, whenever you see density, that's always a trick. Okay, well, nothing's a trick. But the trick is to decide, if I ever see density, I know that the solution involves me deciding on a certain volume or weight initially and then going forward from there. So again, just start writing down what you know. But I'm going to start writing down what I know, not by density, but by deciding a certain number of mils and then figuring out number of grams. And then I'm going to go from there. Now I see that I want to get the total volume. So I'm going to say that the total volume is 100 mils. Okay. Now what I have is, let's see. Therefore I have 150 grams, and 75 grams is A and 75 grams is B. Okay, so I'll write this off to the side. Therefore, you have 150 grams total. Now, I did that via the density. 75 grams of A, 75 grams of B. Okay, so again, I'm just kind of writing things down. I'm going logically, just writing what I know. Now again, I was given the density. That's always a cue. Start making, just decide on something. I decide on 100 mils. It's a nice round number. That meant that I had 150 grams. Now that factoid of 50-50 by mass can't be accidental either. Tell you what, I won't give you any, this is the kind of place where I can give you numbers that don't matter, like the temperature or something. I won't do that. Okay, 50-50, I need to know that, so now I know I got 75 grams A and B. Okay, now I'm looking for VB, I got VA, and look, it's in mils per gram. Okay, so I've got 75. Remember, this is all about units. 75 mils per gram. I knew instantly I had done that wrong because the units didn't work. 75 grams times 0.7 milliliters per gram plus X that they were looking for times 75 grams. Am I doing this right? Let me just check yeah. And therefore, X is, just use your calculator, 6.3, repeat, mils per gram. Okay, anyway. All right, so relatively simple. Remember, I'm not going to give you one this easy because this is kind of childish. I'll give you a much harder one. I'll do that and we'll break. Real quick question, is that a very low density or a very high? That certainly seems unnaturally low, doesn't it? You know, most densities are around 1, is that right? I'm screwing with you. It's 1 over density. Grams per mil is density. That's actually very, very dense. And it's actually the density of corn syrup, by the way. I did look this up. And so let me give you the kind of question I'll ask for you. And this is really kind of a nightmare, and this is more similar to the one I have on the homework. I actually have to admit, I don't quite remember the details of what I put on the homework. Okay, so here's the question. Solution with the density of I'm going to stick with the same 1.5 grams per mil. Let's see. Okay, it's made of corn syrup. Took me a while to find this one. Corn syrup, the molecular weight. Corn syrup has a lot of stuff in it, so I just said it was like 180. I think that's like glucose or sucrose, I think. So I just that's a little bit made up. There's a lot of stuff in it. And the partial volume of it, let's call that A, is 126 milliliters per mole. Notice that I'm switching up on you. This is how I made it harder. I've gone from mils per gram to mils per mole. Why? Because I can make it a little bit harder, and this is a freshman chemistry type question. Okay, corn syrup with that molecular weight and that partial volume and sulfuric acid. And these are real numbers again. Sulfuric acid, the molecular weight is 98.1 grams per mole. It's the only acid I'm actually afraid of. Sulfuric acid is insanely dangerous because it's very pure. And we'll call that B, and its volume, mils per mole, is 62.13 milliliters per mole. Okay. And, oh God, what are you even trying to do? I think you're trying to, okay. Now, it's not even clear. The question is, what is percent composition by mass? Okay. Now let's look at this. This looks horrible. Again, I know my writing, I don't like to write the equations out, the question out on the board, so it's not very good English. But this looks horrible to me. It's a mess of numbers, and it's all very abstract, right? I've got a density. Okay, I know that the density gives me a volume. The volume has to be a partial volume times, it looks like moles. Okay, I got a partial volume. I have a molecular weight, but not moles. Okay, so it looks like I got a major hole there. I've got the same sulfuric acid. Composition by mass, where the heck is that in that equation up there? I don't even see it. Okay, put on your logic hat. Just start writing down things you know, and what you're missing will become clear. And of course, what you're missing is actually the answer to the question, what's the percent composition? I'll just keep working downward. Well, here we go. Okay, so I'm not even going to dare try this without my own notes because it's that painful. Okay, now clearly what I want to do is I've been given a density, so decide on a volume. So I've got 100 milliliters. Now therefore I have 75. No. What have I done? Well, no, I'm being an idiot. I have 150 grams. That doesn't look good. 150 grams total. Okay, you saw what I did there? I almost started writing 75 grams corn syrup, 75 grams of sulfuric acid. I don't know that. That's actually what I'm being asked. You see, I'm just writing down stuff I know, and I caught myself making a mistake. You wouldn't do that on the test because you would only have one question. And now I'm kind of getting it. I'm realizing that I don't have the mass of sulfuric acid. I don't have the mass of corn syrup because I don't know how this gets divvied up. But that's the question itself. Now that gives me a much more clear answer how to do this. Okay, next thing I'm going to do is I'm going to write down, so I've got 150, wait a minute, 100, what do I want to do? I want to do corn syrup. So I've got 126 milliliters per mole. Okay, and then I've got I need to get the number of moles. So that means I'm going to have a certain weight and then a molecular mass. The molecular mass is 180. Okay, 1 over 1 over x. Okay, so mils, moles, moles. Okay, what I'm missing is grams, all right? So you follow me here? 126 mils per mole. I just need to get the number of moles. I know the molecular weight. Now I need to know the number of grams. Okay, the total number of grams is 150. So if I just knew the percent times 150, I would have it for half of it, right? I'm only halfway there. Okay. Number of grams, I don't know what it is, divided by 180 gives me moles, times 126 is corn syrup's contribution. Now we do the same for sulfuric acid, 62.13 mils per mole, times the molecular weight, 98.1 gram per mole. So moles are on top. Now, here's where I get a little flummoxed. I've got my unknown of percent by mass of corn syrup. I've got one equation. I cannot insert y percent times what is the last thing I got? Times 150.
1 minus x.
Right, it's 1 minus x. There you go. Right, you couldn't insert the letter y percent, x and y percent. Remember, it's not guaranteed that it's equal, right? You couldn't, if you use x percent and x percent on both, then it would have to be 50-50. But notice that you've already decided that, which would not necessarily be correct. But the percents have to add up to 1. You see that I kind of like this question because you have to think a little logically about this, and that you're 20 years of age, you should be able to do that without me telling you. Notice that I'm telling you to do that, regardless. So let's just carry this through so that you practice with your calculator, make sure you can do this. And this will be a freebie. I really want this just to be a freebie. So I actually, right before class, when I was screaming at my computer, I actually calculated all this, and these are the numbers I got. And by the way, x is 0.5, or 50%. Of course, if you gave me 0.5, I know you need 50%. I wouldn't dock off. Oh, by the way, and if you're even more careful, you want to see how all of this works together, I asked the same question twice. This was the exact same solution, re-expressed in a very different way. But all the numbers are actually identical. I just flipped a lot of them, right? I went to grams per mole. But if you double check, these are actually the same thing. And so that might be something I just left that for you to do in case you feel like it. You don't have to. It's part of the question here on the test, but there you go. So anyway, I said I'd end early. That's all I got. This is definitely